So we'll be discussing about the properties of polygons. When we say polygons, the term polygon was derived from two Greek words, polus, which means many, and gonos, which means angle. Thus, polygon literally means many angles. How do we identify a polygon? A polygon has two parts. The one is the side, and the other one is the vertex, or vertices when it's plural. What is a side? A side of a polygon, as you can see here in our right image, this is a line segments joined end to end. While vertices or vertex, these are the points where the line segments meet together. So as you can see here, this is your vertex, this is your vertex, your vertex, your vertex, your vertex, and another vertex. And for each vertex, there are line segments that are connected to each other. The following are examples of polygons because each sides are connected by a line segments. So this is a polygon, this is also a polygon, this is a polygon, this is also a polygon. The figures below are not considered as polygons because they are not made up of line segments. This shape is not considered as polygon because this is a circle and the edges are curved, as well as this one there are curved edges, and this one as well it has a curved edges. So again, when we say polygon, your sides must be line segments that are connected to each other and has vertex. While these three shapes here, this and this one has vertices, we cannot say that they are polygon because the edges are curved. How do we name a polygon? A polygon is named by writing the letters of all its vertices in consecutive order, meaning that you have to follow an order in order for you to name them properly. This means that the next letter of the name of the polygon must be a vertex consecutive or adjacent to that previous one. That is, they share a common side. The first letter used in naming may be any of the vertices in your polygon. As you can see here, we have a polygon. You can name this polygon on the right as polygon A, B, D, C. It may also be named as polygon B, A, C, D, or polygon A, C, D, B, as long as you follow the consecutive order of your vertices. But it cannot be named as polygon A, B, C, D. This is incorrect. As well as B, A, D, C. This is also incorrect. So you must follow the consecutive order of your vertices. So it can be polygon A, C, D, B, or B, A, C, D, as long as you follow the correct order of your vertices according to the given polygon. As vertices that share a common side, we call them consecutive vertices. Sides that share a common endpoint are called consecutive or adjacent sides. Polygons are named by the number of their sides. The Greek equivalent of the number is used as a prefix and is followed by the suffix gon. Polygons with 3 and 4 sides are exempted from this rule and they are named differently. So we have here the table. So for a polygon with 3 sides, we call it a triangle. A polygon with 4 sides, we call it quadrilateral. A polygon with 5 sides, we call it pentagon. A polygon with 6 sides, we call it hexagon. A polygon with 7 sides, we call it heptagon. A polygon with 8 sides, we call it octagon. A polygon with 9 sides, we call it nonagon. And a polygon with 10 sides, we call it decagon. So on and so forth. The number of sides in a polygon is the same as the number of vertices as well as the number of angles formed. Diagonals of a polygon is another part of a polygon. It is a segment that connects any two consecutive vertices of the polygon. So, as you can see here in our image, this line segment here is our diagonal from this vertex up to this vertex, as long as the vertices are not consecutive, or um, they are not together in the same line segment. So we call this as your diagonal. So if I put another line segment here, this is another diagonal. So that is how we form our diagonal. To get the number of diagonals formed by a polygon with n sides, meaning we do not know the number of sides, you can use the formula number of diagonals equals n. This will be replaced by the number of sides of the polygon that you are looking for its diagonal times parentheses n minus 3 divided by. So for instance, I am looking for the number of diagonals of the hexagon. So simply, I will replace the letter n. So that is 6 times parentheses 6 minus 3 divided by 2. So we subtract first 6 minus 3, that is 3. So 6 times 3 divided by 2. 6 times 3 is 18. 18 divided by 2 is 9. So the number of diagonals for hexagon is 9. If I have a nonagon with sides is equal to 9, we can have it as 9 times 9 minus 3 divided by 2. 9 times 9 minus 3 is 6 divided by 2. 9 times 6 is 54. 54 divided by 2, we have 27. So the number of diagonals for a nonagon is 27. So that is how we solve the number of diagonals for each polygon. We just simply replace the value of n to any number of sides of each polygon. A polygon may also be categorized by the lengths of its sides or by the measures of its angles. A polygon is considered as equilateral if all of its sides are congruent or have an equal measures, and it is equiangular if all of its angles are considered as congruent. If a polygon is both equilateral and equiangular, then it is considered as a regular polygon. Otherwise, it is called an irregular polygon. So as you can see here, we have two triangles. The first figure, this one, is an example of a regular polygon. All of its angles are congruent. So as you can see, these are the three angles. They are all equal. And so are its sides. So the sides here are also equal. So we call it regular triangle. While this one, the second triangle or the second figure, is an example of irregular polygon because all of its angles, this angle, this angle, and this angles, are not congruent, and neither are its sides. Consider the situation below. In a math class, the teacher told her students to cut out a regular polygon from a piece of paper and determine how many diagonals it has. So Judy cut a four-sided shape. What kind of polygon did Judy make, and how many diagonals does it have? Determine what kind of polygon Judy made. So as you can see, it is said that Judy cut a four-sided shape. So remember that a four-sided shape is a polygon, which is what we call a quadrilateral. And a quadrilateral has four sides. So to solve the number of diagonals, we simply follow the formula n times n minus 3 divided by 2. Replace the value of n by 4. 4 times 4 minus 3 divided by 2. And then 4 minus 3 is 1. So we have 4 times 1 is 4 divided by 2. The number of diagonals for this quadrilateral is 2. Determine if this figure below is a polygon. If it is, tell whether if it is regular or irregular. So the figure shown here is a closed figure whose line segments as at its sides. So these are all line segments. Therefore, we can consider that it is a polygon. It specifically has four sides or four edges, and it also has four vertices or four corners. So 1, 2, 3, 4, and also we have 4 angles. 4. Thus, we can call it as quadrilateral. Since its 4 sides and angles are not congruent to one another, this quadrilateral is an irregular polygon. Give the number of diagonals in this decagon. So, if you see this figure, a decagon has 10 sides. So, n times n minus 3 divided by 2. So that it's 10 times 10 minus 3 divided by 2. 10 minus 3 is 7, so 10 times 7 divided by 2 is 70 divided by 2. So the number of diagonals is 35.